Hello, this will be an example of our compound inequalities. This word problem here, it's not the best questioning problem, but it does ask us to write an inequality that represents the distance we travel to your friend's house and basketball courts. What some people don't understand is this 2.25 miles is how far your friend lives from your house. The problem is they don't tell us what direction, so your friend could be living over here, or your friend could be living over here, or down here. The first thing is that a lot of people think that we need to find the distance across here. Well, that would be an exact distance, like an equation, and they're asking us to write an inequality, which suggests that we need to find a minimum and maximum distance possible. The closest that your friend's house could ever get to the basketball courts would be right there. Let me go ahead and erase the rest of that. So the closest your friend's house could ever get to the basketball courts would be right there. Now, if we know that this total distance right here is 6.5, and we know that this distance right here is 2.25, then the remaining distance right there would be 4.25. 4.25. So the minimum distance from your friend's house to the basketball court would be 4.25 miles. Your actual distance that the friend or you would have to walk from the friend's house would be somewhere greater than that or equal to that, but less than or equal to some maximum distance. Now, the maximum distance would be where the friend's house was on the other side of the inner circle. So not only would they have to cross the 6.5 on this side, but they would also have to cross the 2.25 on this side as well, and that gives us a total distance of 8.75 miles. Now, we can't just leave it as less than or equal to 8.75 miles. I have to have a low side on there, because if I didn't, then this would suggest that I could have negative distances or a distance of 0, which we know is not possible. And that is why we have to show this as a compound inequality, where we have a minimum and maximum distance. So that's just from your friend's house to the basketball courts. The next one says to write the inequality that represents our travel if we go to our friend's house first and then to the basketball courts afterwards. So let's start with the minimum side. So we've got a min, we've got a max. We know that we have a distance that's going to be somewhere in between. So the minimum distance, again, would be if the friend's house was right here, and then you were to travel from your house to the friend's house, and then friend's house to the basketball house, and that's all in a straight line, so that minimum distance then would be 6.5 miles. But the maximum distance, a little more difficult to understand. You still have to have the friend's house on the other side of the circle, but you're going to go from your house to the friend's house, which is 2.25, back past your house, another 2.25, and then the remaining 6.5 miles to the basketball court. So your maximum distance on that side would be 11 total miles. I've gone ahead and added another example, because you'll probably see something like this either on the test or the benchmark or the midterm or the EOC. This one actually asks the question a little bit better than the previous question. You live 5 miles from work, and the gym you go to is 3 miles from work. Find the minimum distance, D, between your home and the gym. B, find the maximum distance between your home and the gym. C, write an inequality that describes the possible distance between your home and the gym. Okay, so the gym is somewhere on the inner circle. Work is here in the center. And your home is somewhere on the outer circle. First question, find the minimum distance between your home and the gym. Let's just assume for a moment that your home is right here, the closest you could ever get to the gym's on the blue, would be as if the gym was located right here on the same side of the circles, kind of in line with the work. The question is, what is this distance between the two rings? Well, we know that the total distance is right here. We know that that's 5. We know that this right here is a radius, just like this one is, so therefore this distance is 3. So this distance plus this distance gives us 5 miles. Well, we know that this one's 3, so how much does this one over here have to be? Well, that would be the remaining 2, so the minimum distance would be 2 miles. Next question, maximum distance. Well, let's go ahead and take the gym and put the gym on the other side. So let's say your house is here. Draw a straight line through, and let's suppose the gym was right there. Okay, so that one we know we have to walk past work, which is 5 miles, and from work over to the gym is another 3 miles. So that we now know that our maximum distance, I didn't put a 3 in there, our maximum distance would be 5 plus 3, which would be 8 miles. Now write the inequality that describes possible distances. So let D stand for our distances, and our distances will be less than or equal to the maximum distance, greater than or equal to the minimum distance. And we already said that our minimum distance was 2, and our maximum distance is 8. So we know that the actual walking distance, no matter where they're located on the circle, that's our home or the gym, will be a minimum of 2 miles and a maximum of 8, but it could be anywhere in between.